Okay, so we're on page 412 in your textbook, okay? And you might also know, where it says systems of equations, you might know that as simultaneous
Then yeah.
equations.
I forgot that.
You forget. Okay. Right. If we have a look at these two equations, so the example in the book, we're just going to go through it. So we've got y equals 3 multiplied by x plus 2, subtract 6, and then y equals 4 multiplied by 2x minus 3 plus 1. So, what do those two equations give you? Just in general. They're two separate equations. Could you describe what they would do or show, or how they behave, or tell me anything you know?
They both equal y.
What do you mean by that, though?
Is it a different y? Oh, they're equal.
They are equal, is your statement you're making.
The equations are equal.
And what makes you say that?
Because they are both in terms of y, in terms of the same variable.
So they are always going to be equal, is what you're saying.
Yes.
Yes. Okay, that's what you're saying. Anyone have any different comments? What does it mean if two equations are equal?
They have the same value.
They have the same values. Okay, what values are we talking about? Y value? Just x value? Both?
Overall value.
Let's take one of them. So this shows a kind of a little bit of a weakness in understanding that we could address. Let's just take that equation. What does it mean? So what I'll do to start with, let's to cover that over, shall I? Let's just look at this one, right? What does it mean? What does it do? What's it for? You're telling me what I can do. It doesn't tell me what that means. Pardon? Gives me the equation of a line. Okay. Does it? Does it?
No.
Does it give me the equation of a line?
No. It gives you the equation of points. Infinite points that make them.
Okay, good. You weren't here for that discussion, but it is in the video. We said a line is not really a line, right? What is a line?
Infinite.
And where do these points come from?
From this.
And how? Where do I get a point from?
The -6
The -6 gives me all the points.
gives you a point.
Does it?
No. -6. You do like
From that thing you can find one of the points.
Just the -6?
No, the 3x.
But that's a different point.
Right.
Yeah, how are you about to get?
You substitute y and 1 first as 0 to find the intercept.
Why specifically an intercept?
Because it's on the axis.
And why am I interested in that one?
Because then if you get both of them, that's when you link them together, you can make the infinite number of points. You can draw the.
But can't I just find a different point? Does it have to be the intercept?
That makes
No.
No.
But it's right there for you.
But you know that there is gonna be something with that.
So you might determine that that's the easiest point to find. Is that what you're saying?
Yeah.
In that sense, so -6 you're saying is a point on the line?
What?
Wasn't it
Well,
0?
no.
If you, it's not.
I'm struggling here because you're giving me a number and telling me that's a point, and I have a trouble because how can I put a point on a set of axes if you're giving me one number?
Since you know that the -6 is the y-intercept,
you know that the x value of the coordinate has to be 0. So the
Do we?
point-
Okay, so, all right, there's a question. Is x 0 when the y is minus 6?
Yeah.
Is it?
If it's the y-intercept.
What a y-intercept is.
Hurts my brain.
But this is an interesting point, is it not? This is you. This is a problem that, like, good students have, is that it's so easy to get you to a stage of being able to do a question. But the question for me is, do you really understand what's happening? And if you don't really understand what's happening, you will have to address this at some point. Now, you can either address it now when things are relatively simple, or you can address it in a couple of years' time when you're doing DP and you're trying to do calculus and differential equations and blah, 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 right? So let's try and address this now. Let's just get the fundamentals of what is an equation. What does it do? What do I use it for?
You use it to find values.
Okay, that do what? Well, you keep giving me, like, make up a line,
It's not always.
but that's kind of what we have used to help us understand the equation. All right? We don't necessarily, too many people think, well, the only reason I do an equation is because I get a line. Well, no, we get a line and we analyse the line because that helps me understand the equation, actually. Right? But what is an equation? An equation links two things. All right? It links one number. We happen to call that number x. Okay? It links it to another number. What is that other number? Y. Okay? How do those two numbers get linked? Okay? By an equation, right? So if I write this in here, do you know what that means?
Frequency x.
Doesn't mean frequency, but I see what you mean. Thank you, Neil, but we do put our hands up in these classes, yes? Yes, f for function. This means the function that is applied to x. All right? Why do I apply the function? Well, I want to see the number that comes out. All right? Why would I want to do that? Well, maybe we want to apply it to a real world example. Maybe we've got some values, one value that leads to another. Maybe we've got, this is how far I've travelled, how long did it take me? I'm trying to link two numbers together. So what is the function that has given me the link between my x value and my y value? No, it's not a line yet. What is the function?
X.
Well, there's several parts to this function, which is, well, I take my x and I do what to it first? No, I don't. See, this is the problem. I add 2. If we don't know in what order things happen, when I'm rearranging or solving my equations, I'm going to do things in the wrong order. We have to be able to look at that equation and see what gets done to x to give me the y. So first off, we add 2, and then we do what? Well, we actually, we get an answer, and then we take that answer and multiply by 3. Okay? We get another answer. And we take that answer and then do what? Subtract 6. And then that answer is called y. So if I was to read this in English, I would say, not just y equals, but to find the y value, I must do all of this to the x value. Right? So I take one number, I do this to it, I get the y number. Okay? That makes sense? So we know that if I take, well, you told me that if I take 0, I should get what out? Well, you told me -6, because you told me the y-intercept was -6. Now, this is just another bit of understanding. So you know, because we use an axis, the x number that is put on the axis is 0. That's where we do it, right? So therefore, you're telling me that the number that goes with 0 will be -6. Are you correct? 0 add 2 is 2. 2 times 3 is 6. 6 take 6 is... So actually, my x and y, what are called coordinates, but before we put them onto a set of axes, are called an ordered pair. Okay, it's called an ordered pair. We can now link what and what? 0 and 0. Okay, so we've linked those two numbers together. We know that for that particular equation, 0 and 0 go together. All right, if I put 0 in, I get 0 out. So working this way is called, well, you already know what it's called, but if I work this way along my flow diagram, it is called substitution, right? Why is it called substitution?
You're substituting the unknown.
Yeah,
answer.
well, it's not even an unknown, is it? I can't substitute an unknown. I choose a number, I put it in, I get a number out. Nothing's unknown. All right, so I substitute. What's the other thing we do in maths? There's really only two things we want to do. We substitute or we go the other way, and it's called solving. So you substitute in means we use it in one direction. We solve, we go the other direction. So substitution is when we know the x and we work out the y. Solving is when we know the y and want to know the x. Simple as that. All right. Why would I know the y and not the x? Can you give me a situation? Because you all know how to solve. You were doing it yesterday perfectly well. All right, we went through how to solve. Why would I want to solve? Could you give me a situation? You give me a real world example of substitution and then solving. No? I've got one for you. I have a need to have my living room decorated. What do I do? I'm not going to do it myself. I'm rubbish at it. So what do?
You call someone.
I call someone. And what does he do? He stands in the room and goes, "It's going to cost you a lot, this, mate. It's going to cost you a lot." All right? And he goes like this. It will take me 10 hours. That's going to cost you $5,000. How do you work that out? Yeah. He has an equation that links his time with the money I have to give him. So they're the two numbers that get linked. So he has an equation of hours and cost. So he will substitute in the number of the hours he thinks it's going to take, and he will work out how much it's going to cost me. All right? That's substituting in, yeah? Where does his hours come from?
How much work has to be done?
Yeah, he's had an estimate, or he's got experience. So you know someone that's got a lot of experience. So he's substituted in. So my X number could be my hours. My Y could be the cost of it. So where would the solving bit come in? That's the substitute. So the guy has told me it's going to take me 10 hours. This is how much it's going to cost you. There's another situation that could happen.
You have to figure out how much per per hour to pay in case like it doesn't take him 10 hours? It's just like an estimate.
Well, that changes the situation a little bit, but I do get what you're talking about. I would agree, yeah. It's working about the hours, isn't it? But I'm kind of trying to keep things a little bit similar. What if I went to him and went, oh, all right, I get you. I've only got $4,000. How long will that get me? I'll finish up. So what would he have to do? So he would have to work backwards and go, all right, well, if you've only got 4,000, let me work out how much time that enables me to give you. Right, and then he can say, oh, well, in that time, I'd only finish half the room. Are you sure? Right, so there's a real world example. So do you understand? So substitution, if he tells me how many hours it's going to take, he will then work out the cost. If I tell him how much money I have, how much I can afford to pay, he will tell me how many hours he will work for that. Does that make sense? Now, it might be a different situation, like it might just be how long will someone stand and hold a sandwich board advertising your shop for you, right? So they need me for 5 hours, I'll tell them how much I've charged for that. If they say, oh, I've not got that money, well, I'm only going to stand there for 2 hours, type of thing. Make sense? So we're linking two numbers together, we have a function that works out. So what would the function comprise of if I'm talking about the guy working out how much it's going to cost to paint my room? What would he look at? The size of the room. Also, you think you've already said it. How much he would charge an hour. Quite often people have a how much they charge just to turn up in the first place. All right? That's how they make their money. They turn up and they go, right, so it's costing you $50 already. All right, if you would like me to start, I will now charge you this much. If you don't, you still have to pay me $50 for turning up. All right, that's how it works. So this is the two numbers. Now, where does our infinite number of points come from? But why would I need an infinite number of points? Why would I need more than 1 point? Yeah?
If you only have 1 point, you have no idea where the line
Forget slope and things. Slope are what we use to analyse a line to find the equation. We're not at slope or anything yet. I've got 1 point, right? Let's say 0. This is nice. 0 hours, 0 cost.
And then if he works X amount of hours.
What would 3 hours cost me?
How much are you? 15 is hours.
3 plus 2 is... 3 plus 2 is 9. What?
No, I went to the end.
5. 5 times 3 is...
15.
15, take 6 is... 9, okay.
I went to the end.
I went to the end. So 3 and 9, that's another pair of numbers. All right? Could I get another point?
Yes.
And what does it mean?
How much it would take for a different amount of hours.
Yes, so in this situation, should there be an infinite number of points? Really?
No.
Why not? Why wouldn't there be an infinite number of points in this case?
Probably not going to work for like 5 hours and like 20.
Exactly. It becomes irrelevant, doesn't it? This guy is going to say, well, I only work for whole hours. I don't work for 1.13 hours. Right? So would I draw a line in this situation?
No.
No, just a series of points with big gaps in between. So the line, however, is an infinite number of points. If I don't have a reason to draw a line, that's because there aren't the infinite number of points in between. Now, let me explain again. The slope and all of that is just a way of determining what the equation is from the line. If I already know the equation, I don't need to worry about slope at the moment. Right, let's take a step on then. So what does it mean? So if one equation links two numbers, how many points could I, let's forget the cost and the hours, how many points are there that get linked with this equation? So there's no situation, so therefore it's infinite, right? I can choose any value of x and get a value of y out, yeah? Right. So, if I incorporate a second one, what will that equation on its own give me?
Infinite.
An infinite number of points. Are they all the same?
No.
Why not? Because if I take the same x, am I doing the same thing?
No.
No. All right? I'm not doing the same thing. So therefore, is it likely that the y that I get out is different?
Yes.
Okay, so let's have a look. So this was equation 1.
Wait, what do you mean if you?
This is equation 2. So here are my numbers. So what if I put 0 into the second equation? What do I get out? So 2 times 0 is 0. 0 minus 3 is... So the whole thing is negative 11, right? So those, they're not compatible, right? They give me different pairs. What about if I put a 3 in? So 2 times 3 is 6, 6 minus 3 times 4 is 12, plus 1 is 13. Are they the same? No. So these could be two different workmen charging different amounts. But what do you notice? Well, it doesn't work because the negative 11 means he's paying me, but you get the idea. Two different men charging, or women, charging different amounts for their hours, right? So what does it mean to solve simultaneous equations? Yeah. That mean what?
To find like two values that mean what the like overall like what's the better option?
Like what they are like.
What's the better option? What? Say again. This, do you want to answer these equations? You
Yes.
done it? Yeah? Okay. It's funny, isn't it? Yet none of you can tell me what it actually means. It's great. Don't we just do it? You know, I just get the right answer. Mr. Potts gives me a 7 in my test because I got something wrong, so it's not an 8. Okay? It doesn't matter that I don't really understand what I'm doing as long as I get it right. Oh, until I get a criterion D question, and then I'm screwed. So, any ideas what simultaneous equations mean then?
At the same time.
Oh, at the same time. What could be at the same time?
Solving.
Solving.
Oh! Is it like one of those things where it's like if they like work together, how much will it cost?
Like,
No.
it's interesting, right? What happens? What do you do? Let's go back to what you've actually done with simultaneous equations. What do you actually do? Safia, you tell me. Let me be honest. I've just picked on you because you were head down and not paying an awful lot of attention and nothing. Then this is the important bit, though: the understanding, the thinking, the right. We'll write it down in a bit, but I want you to think. What do you get when you solve simultaneous equations? Just one value. Two values that represent that are what? You get an x equals and a y equals. Just one? One x and one y? Or two x's and two y's?
One
X,
Pair of X and Y and
a pair of x's and y's. An ordered pair, right? But do we get two x's and two y's, or do we get one x and one y?
Two pairs of X
One
and
X
Y.
and one two X's and two X. Two X's and two
God,
Y's.
you lost it, haven't you?
No, I have it. No. Two ordered pairs. Because that's what it says. That's what it is. That's
I get the ordered pair, but I like the ordered pair, but how many ordered pairs do you get?
Two.
No, you get one.
You get one.
One. You get one pair, don't you? You get when I ask you to solve simultaneous equations, you've got two equations, both with x and y. They link the x and the y, and what you get at the end is one value for x and one value for y. So what does that mean?
A one-ordered pair.
And what does that mean?
1 point.
Well, what does that represent?
One value.
And what does that represent?
And one
A
data
line.
point.
1 point represents a line.
I'm so confused.
1 point represents 1 data point.
Yeah.
There you go.
All right.
She just added the word data.
But,
Recorded.
but at least she's not saying.
I said data point.
At least she's not saying a line. What does it mean in terms of our two work people?
Their cost per hour.
Wait, I'm so confused.
So I've got two equations that link hours and cost. If I solve them as simultaneous equations, I get one value for x and one. What have I got from two different equations, which we've already seen gives me different hours and money? What does it mean to solve the simultaneous equation to get one x and one y?
The difference between
No.
the two.
I thought
This is the fundamental problem. What it means is if the two lots charge different amounts, okay? So the second one might charge me less per hour, but more to start with, or something else, yeah? People charge in different ways. But what potentially could happen is, at some point, the one that was more expensive becomes cheaper. So if one becomes cheaper and was more expensive, what must have happened en route to becoming more expensive? Logic. If one was cheaper than the other, and then at some point after a certain number of hours becomes more expensive, what must logically have happened along that path when we work it out?
Like how their prices, like as the hours go on, their prices might get lower or higher.
You're missing the thing.
One might take longer to do one job than the other.
No, I'm not thinking about that. It's not what I'm thinking. You could be right, but that's not what I'm thinking about.
The like base like thing you said when like they go to the thing is like larger for one of them. So that's why I was like.
Well, I'm not even thinking about how it's made up. What I'm thinking about, what must have happened if one of them was more expensive, okay, than the other. But if we work out, let's say we sit down with both of them together and we work out what's your price for none hours, right? None, -11. What's your price for 3 hours? Right, I charge 9 each. What's your price for 8 hours and so on, yeah? And we sit down and we work out a table of values. If one of them was cheaper to start with at low hours, but becomes more expensive at longer hours, regardless of how it happens, but if it was cheaper and it's now more expensive, what must have occurred at some point?
Yeah.
No problem.
They
So what does the intersect mean?
When they both cost the same.
Okay. So if one was cheaper and becomes more expensive, the other one was more expensive, becomes cheaper. At some point, they must have been the same. Yeah? Got it? Must have done. If I was cheaper and I'm more expensive, okay, we must have been the same at some point. So, what does it mean to solve simultaneous equations? Neil? So find that point. Now, I'm sure you'll remember the intersection bit. But to solve simultaneous equations, we are looking for the one point, or potentially more, depending on what functions we're dealing with, where the x value I put in, the same one, whether it's 0 or 3, gives me the same y value. Does that make sense? Yes. So that's what it means to solve simultaneous equations. Okay? Now it's important that you understand that. All right? So let's write that down. I might pause. So this is the situation we're looking for when we solve simultaneous equations, right? What value of x can go into more than one equation and give me the same value of y? Now then you start looking at, well, if I do draw the equation as a graph and draw a line, what does that look like on a graph with two lines? Well, you've already told me.
Intersection.
An intersection where the two lines cross, right? Where two lines cross, if we start thinking of lines as an infinite number of points rather than a line that I drew with a pencil because I was asked to, right? When two lines cross, it means that one point must be shared between two equations, right? We think of it as lots of dots, then where they cross, there must be one dot that represents both lines, yeah? Both functions. So simultaneous equations when we're finding that one pair of numbers that works in both. Now it might be that there's 3 equations, 4 equations, they all share the same thing. So that's our basic understanding of what we're doing when we're doing simultaneous equations. Now maybe then it will help you understand what we're actually doing. So let's have a look at these two equations again then. 3x plus 2 minus 6 and y equals 4 lots of 2x minus 3 plus 1. So I'm looking for this situation. That's what I'm looking for. All right? So how can I do it? Well, I'm saying that the x's should be the same and the y's should be the same, yeah? I am. That's what I'm saying. That's what I'm looking for. I'm looking for, in these two equations, x goes in, the same x, and the same y comes out. Now, I could try and do that by trial and error, but there's obviously a better way to do that. So any ideas? Well, if we now understand what we're looking for, we can make certain conclusions, which is, well, what do I know about the y's? They're the same. So if this is the same as this is the same as this is the same as this, because that's what the equal signs means, what's the other conclusion that can be made? The equations are the same. So I could write 3 lots of x plus 2 minus 6 also equals 4 lots of 2x minus 3 plus 1. So this is where we come down to our equivalent forms again. I've not done anything in terms of rearranging, anything like that. I have written down another equivalent form that is also true. And it's using my logic, which is, if that's the same as that, and that's the same as that, then this has to be the same as that one. All right? Has to be. Just logic there. And now I've got a situation where, well, I've only got x's, the y's are gone. But it's not a problem. So what do we do from this stage? Yeah.
Make the x's equal.
So I'm going to try and figure out what 1x equals. And how do I do that? Well, we did that yesterday. So we're in exactly the same situation we were yesterday now. So what would you like to do first? Expand them? Should we expand? So 3x plus 6 minus 6 equals 8x minus 12 plus 1. Collect like terms. So that gives 3x plus 6 minus 6 is 0, and this is minus 11. Okay? Now, do you remember yesterday I said about we're going to write down all our equivalent forms. That might be a bit different than you're used to doing, but we're just doing it at the start just to get used to certain things. So what could be my next stage?
To add the x's together.
I can't put x's together.
No, like take subtract 8x. I'm not explaining.
Subtract 8x. I know what you mean. I'm just trying to get you to use more appropriate language. So I'm going to subtract 8x from this side. Therefore, I have to do it from that. Now, the reason why I would like to get into the habit of writing it all out, even though eventually you won't, is because then we can spot the potential mistakes. When we subtract 8x, we must subtract 8x. It goes in that order, which means we end up with negative 5x. Now, some people would write it as positive 5x. Right? Just one of those mistakes that happens. But if you write it out, you can then see and you can check your working. So minus 5x, and this would be 8x minus 8x is 0. And this is also what happens. People forget the negative because they go, oh, there's nothing to subtract from now, so I'm just going to write 11. But what is 8x minus 8x? 0. And what is 0 subtract 11? Negative 11. Okay, so it makes sense that the negative is still there. All right. Now, do you remember what we did? So we introduced a new way of writing this, which is, how do I then solve for this? Divide by negative 5, or, so negative 1/5 times negative 5x, and then I could do negative 1/5 times negative 11, okay? Just to get used to that form. So what's negative 1/5 times of 5? That's just x, and this becomes 11 over 5. All right? So I found the x that if I put in gives me the same y. I don't know what the y is yet. How do I do it?
Plug it in.
Plug it in. Okay? Now, really, I should be able to plug it into either of them, yeah? Should work, should give me the same answer. All right? So which one would you like to plug it into?
3x.
3, so I'm going to use the 3x plus 2 minus 6. Okay? So y can be found by doing 3 lots of x plus 2, then subtract 6. That's what I read that as. Y can be found by doing. It's amazing how many people can work out the x and then don't know how to do the y. Okay, so I've got y equals 3 lots of 11 divided by 5 plus 2, subtract 6. Okay. I'm keeping it as fractions so I don't need to use a calculator. Because in the book it tells you 2.2, but... So what can I do? 33 over 5 plus 6 minus 6. How easy is that now to do? 33 divided by 5 is my answer. All right. Which I could write as a mixed number if I like. I can't simplify it, but we're all good. So my answer is y equals 33 over 5, which I'm much happier with you guys than decimals, by the way. Like to be able to use, there's no need for a calculator there. Okay, so we've got now, what does that mean again? That x and that y, remind me? That's the point of intersection, which means that if I have 11 divided by 5 hours, doesn't make sense number-wise, they both charge me the same amount of money, right? Either side of that point, it will be different. But that's what the simultaneous equations means. So we've got one method covered. You've obviously all got 2 other methods, which are what and what? Remember? So you've got the elimination methods.
Wait, there's 3.
There's the one we've just done,
Then there's substitution.
the equating methods. Then there's the substitution methods, which maybe makes sense now, and the elimination method, which we can go through. Okay? I haven't dismissed anyone yet. My watch says 18 in big blue 18. 19 now. Don't get up till I say. All pack up.